So this is going to be an introduction, just information on Profinet bus and Profinet, just for information. So it's going to be brief. So if we have a little look here, there's an organization to PI International that you can just write PI International. You're going to get to their homepage. Most of this information is off of this homepage. Use organization, you can read this by yourself, but be careful. This is Miracle Medicine, and they all these field buses. Of course, it's the best field bus in the world, but it's not. There are better. They have their pros and cons, all of these. There's a little history about it. And Profibus, that's a bus. Here's a cable. It's this color. And it's 2-way, and they have special connectors, RS485, and they must be terminated at the end of the bus. If you don't terminate it properly, it's not going to work. Also color codes too, because when you do the connection here, there's a green and a red one that you have, so you're not, as I say, switching your bus. That's not going to work. And here's the end connect that you usually end up, and something in the front, you can turn it on and off. Here, remember, in and out for the cables, and also the color codes for the twisted pair here. And you see the shielding and so on. So it's up to 12 megabits per second, dependent on the length. The longer it is, the lower the speed will be, because then the signal just attenuates along the line. And here is the end resistor, and this is also multi-master, but here's the master. And here the resistor has to be. So here it's in and out on these connectors, and you have to switch on the end resistor and the end. And if you're doing some error searching in the network, look for the end resistor. Maybe if I switch on the end resistor here, so you're not going to see the slave at all, so it doesn't exist. Yeah. Yeah. And then there are two here, there are two profiles. There were 3 of them, but you have something called the distributed periphery. That's where we just put our instruments out in the field. And then we got something called Profibus PA, process automation, where we got a smart instrument, which also supply power to these components, instruments here, so we can place them into EX zones and so on. Yeah, discrete, it's a lot for discrete and factory automation, and the PA is then for process automation. And usually to connect this, you have a gateway from PA to DP to get your data in here. So that's usually a normal way of doing it. This is becoming more and more obsolete, of course. So here is a few highlights. You can read this by yourself. There's not the Profibus PA instruments, long plant life, 10 to 20 years. And here are priorities, you know, here real-time processing, cheap, fast, high positioning, accuracy drives, for instance, has to be fast, and you have to position them correctly, and so on. And here, of course, is correct data for process automation and so on. So important. Here is you're running so fast that even if your data are not correct, you know, you can do anything about it. Yeah. So this is what it is, decentralized distributed peripherals. That's just what the DP says, you know, what's used for a lot for factory automation. And here's the speed, dependent on the length of the cable, and also how many connectors you have. And so I've seen a really bad example where they just cut the cable, didn't connect to shielding, whatever, and we had to go down to 9,600 BPS, or rebuild the entire cabinet. We opted for 9,006 and told the customer, maybe you should get someone to review this cabinet for you. Yeah, and this EX zone is also important. Then you need control with your power supply, and that's what you do with the Profibus PA. So here's the smart instruments. The OC model, as usually, you know, physical, EIR 485, optical, and so on. And you need this fieldbus data link, the data link layer, and then you have these interfaces application. There are versions, version 0, 1, and 2. So it's layer 1, 2, and 7, and all this rest of the OC model you don't need. The topology is, yeah, you can look at here. It's RS 485 here for this, and then you have got this fiber optic option. You know, then you need fiber optic converters and coupling and so on. And here you got a PA with power supplied on the instrument to a cable, bus feeding, explosion proof and so on. Yeah, and both of these can use fiber optic too, but of course you don't supply power on a fiber optic cable. Yeah. Yeah. So this is encoding, Manchester encoding, and so on. Fiber. You can read this for yourself. Number of stations is a little important too here. 32 station, but then you need repeaters and so on, especially here too, with repeater. Yeah. So this is the hybrid. Yeah, all PA networks, so you need a Profinet, so some Profinet backbone network. That you need these interfaces here, and of course Siemens, they have some of these. These are old, and here's a new one. This is for the S7300 series, I think, and this is for the 1500, where you have. No, yeah, okay. This is also for Profinet. So you have couplers, as Siemens call them, how to connect them, get it into the network and into the PLC. Yeah, and here's another one, a gateway from, I don't know what it says, PN gate it is. Profibus, Profinet, so it has converters between these nets too. And here there's a link down here, so you can have a look at it. Link, maybe you can see the link. Yeah. Yeah. And again, there's a little more information on interfacing this stuff. The way you address these devices too, you do some in software, but then you also have dip switches and some older devices, and they see here. So if I want a 32, that has to be 32 or 16 or something, that switches on and the rest is off. But here is 2, and then you get 3. So you just add them up. And this address has to be unique. If you have 2 devices with the same address in your system, it's not going to work. Yeah, and then for the Profibus network, you have, for every device you have something called a GSD, general description, system description or something file. I don't know what the short is for. Yeah, general station description, of course. Originally was German Gerätestanddatei, which means that, okay, this is description for the Gerät, the device description. Yeah, that's what it says, basically. All devices are shipped with a GSD file, and they can be downloaded from the web, and you have to integrate it in your programming device to use this, because this is telling you how does this device work. So you need to know that to communicate. What kind of data does it have? What can you write to it, and so on. And they are in markup languages, some XML files. And you can read them too. So if you open a GSD file, there's going to be XML in this you can read. And here is an example that you can go to. Again, I'm probably sitting not correctly. So here's an example that you can have a look at. And again, there will be an example here. Profibus to Profinet. So here's the Profibus, and here we've got the Profinet system architecture. And this is peaking out, and the Profinet is growing as of 2020. So this is pretty much obsolete. Yeah, for various reasons too. But they are in an install base, and these systems, they are living for a long time. So you're going to run into these DP systems for quite a while now. But new systems should be Profinet, and newer system, of course. We hope for OPC-UA effects and get rid of this. Yeah, and here are some videos that you can learn. This is again from the Profinet International. You can find some videos that you can have a look at. This is just for information and quick information purposes. And then you have connectors too. Profinet connectors when we look in Profinet, and you get these various types of connectors you can have. Of course, you can also have this RJ45 multi-pin connector, and then you have other types depending on what kind of network you have and the robustness of your network and the shielding and whatever you need. And here is for you to read. We get to something. There are 3 profiles for Profinet. You have got real time. We've got special frames within these telegrams with real time. This is an Ethernet frame. And you have cyclic redundancy check and so on. Oh, that's the field, the check down here. A cycle counter and so on. So this is the standard Ethernet frame, IPv4. Yeah, I don't know. I don't think it's for IPv6 still. You know, so that's the real time, and then you have got some user final that you can have just standard frames in, standard data in here too. But then you get into something called isochronous real-time communication, where we need the deterministic communication, and field buses need deterministic communication. And then you have a special framing, and it says interval, because then you bypass the TCP stack and you go directly on, and the switches, they have to play along too, so you get just a channel through here. We're going to look at a little bit at a later, but then you need a special component. It's called enhanced real-time Ethernet controller in your components to get these time slices here. They have to be fast, for instance 250 microsecond or something. You should have to be able to transmit data. So that's how they bring this deterministic stuff into Ethernet, which of course is probabilistic in itself. And here again, it's a link to where this information is taken from. And here is the deterministic Ethernet. So how you do it is you have a device, you need a switch, and the switch has to be in the device too. And you need buffers, and then they need to have the exact same time, because at some period of time you are going to get a channel through between 2 devices, and the rest has to be buffered here. And then when this transfer is done between this device or whatever you are going to do, then of course the ERTIC chip or this Ethernet controller is going to just return to normal communication for a while. Can be real-time data in here, and then again after 250 microseconds again, this channel has to be open and transfer, and then it goes on. There's another thing too, you have to avoid collision too in a deterministic network, so it has to be 4 wires here, 1 for transmit and 1 for receive, so you don't get collision between the devices and the switches. And then of course these clocks, they have to be synchronized really. You can use, for instance, the PTP position time protocol to synchronize these devices. It has to be like this. So that was the real-time Ethernet. So okay, what we looked at really fast here was Profibus and Profinet. Just for information, you can read what's on the video yourself. You can pause it. I didn't talk about everything here, but I highlighted some of this stuff. And Profibus is legacy and it's obsolete, but you're going to run into it because it has a large install base, especially in Europe. And Profinet is now replacing Profibus. And then hopefully then again, OPC UAFX is going to replace Profinet later on. And parts of this OPC UA at least, there's some of the technology that's been used in Profinet built into UPC UAFX, and that's probably not too good either. Maybe we should have looked at the EtherCAT instead when you look into this deterministic real-time Ethernet communication.